Hi everyone. So today we will discuss problems based on calculation of center of mass or center of gravity. So here in this first question you can see that locate the center of mass of the machine part consisting of a disc 4 centimeter in diameter and 2 centimeter wide. So here this is the disc. Its diameter is 4 centimeter and its width is 2 centimeter. And a cylindrical rod 2 centimeter in diameter. This is the cylindrical rod, 2 centimeter in diameter and 12 centimeter long. Its length is 12 centimeter. Okay. Coaxial with the disc. And they are coaxial. Either this part or this part, they are coaxial. Both made up of a homogeneous material. It means the material which is used for this part or this part, they are same, as well as it is homogeneous. Homogeneous means density throughout it is same. So here if we consider, so we have to calculate the center of mass of this. So center of mass of any object, particularly it is generally the geometrical center of that particular object. So if you consider this part, so center of mass here, it will be the geometrical center of this. Similarly, if you consider the center of mass of this part, that will be the geometrical center of this. But what will be the common center of mass of this object as well as this? It means this part as well as this. That we need to calculate. So here if we consider now we can say this. So the center of mass lies on the axis and the center of mass of each part is midway. Midway, as I was saying, geometrical center. So geometrical center of this as well as geometrical center of this. Now suppose O is taken as a reference point at the extremities of this disc. Now here the volume, as this and this both are homogeneous, so we can consider that the mass of this part or this part, it will depend on the volume, and if the density is same, so obviously it will be proportional to the volume. So here we can see the volume of the disc, it will be 8 centimeter cube, and that of the rod, it is 12 pi centimeter cube. Here it is 8 pi centimeter cube of this part, as well as of the rod it will be 12 pi centimeter cube. Now the material is homogeneous, means the density is same. So it means the ratio of the masses, it will depend on what? The ratio of their volumes, because mass volume into density, it will get cancelled, and it will completely depend on the ratio of these two. So here we can consider this. So M1, if M1 is the mass of the disc and M2 is the mass of the rod, then M1 by M2, it will be 8 pi divided by 12 pi. So it is in the ratio of 2 pi. Now why we are calculating this ratio? Because certain data are not known to us, and here when we calculate the center of mass, in the numerator we have the mass term, in the denominator also we have the mass term. So if we calculate it in terms of ratio, some of the terms that will get eliminated once they get divided, and just because of that, instead of getting into the exact value of the masses, we are calculating the ratio, because that exact value is not needed, and even if it is needed, from the data which is provided, we can't calculate its exact value. That will be in terms of the density. So here that's why we have calculated the ratio. Density is same, so that part is eliminated, and we are getting from here M2 is equal to 3 by 2 into M1. Now if we consider this, so taking origin as the reference point at the left of this, that we have considered, you can see this here, O is taken as the origin. So here it is the origin, this is the reference point. From this reference point we have this x1 as the center of mass of this part, and x2 is the center of mass of this part. Okay. So from this point we have this, so here this entire mass of this, it is supposed to be concentrated here, and for this So for this part, x1 at this from this point is the center of mass of this, and x2 center of mass of this object is at a distance of x2, and this m2 is supposed to be located there. Now here, so using all these relations, so we can calculate the center of mass of the entire system. So when we calculate the center of mass of the entire system, so that you can consider here, O is taken as the reference point, x1 is equal to 1 centimeter, x2 is equal to 8 centimeter. Those values are already known to us. So the center of mass of the entire system, it will be m1 x1 plus m2 x2 upon m1 plus m2, that is m1 into 1 centimeter plus 3 by 2 m1, means m2 x2. m2 is replaced by 3 by 2 m1 that we have already calculated, divided by m1 plus m2, second m1 plus 3 by 2 m1. Now m1, m1, m1 in the numerator denominator, that will get cancelled out and simplify, and you are getting this 5.2 centimeter. Remember, the center of mass is on the axis 5.2 centimeter to the right of the O. This was our this object. So here we have this point O. So from this point at a distance of 5.2 centimeters, so that is the center of mass. So that way we can calculate it. So here, if you just summarize, what was the thing? We have just calculated the relation between the masses m1 and m2, because exact it cannot be calculated because density is not given, and that is not needed also. Once we have calculated this, we have the location of the center of mass of this object particularly, which is at its geometrical center, and similarly for this, which is also at its geometrical center. Taking advantage of that, we have considered m1 x1 plus m2 x2 upon m1 plus m2. Simplifying, we are getting this value. Now if you consider this, now here in this case we have two spheres, each of mass m are placed at the two of the vertices of an equilateral triangle. So this is an equilateral triangle, and two masses or two spheres of each mass m are placed at the two of the vertices of equilateral triangle. A sphere of mass 2m, 2 are of mass value mm, and another is 2m. So here this is m, and this is 2m, is placed at the third vertex. Find the center of mass of the spheres. So we have to, now we have a system. So when we have a system, so this is your equilateral triangle. At the vertex we have two masses m and m here, and here it is 2m. So what will be the center of mass of the entire system? That we need to calculate. So again you can see this. So let us again choose the axis of the coordinate as shown. So let A be the side of the triangle. Once it is an equilateral triangle, so the side length it will be same. So suppose length value or the side value it is A. Then the coordinate of the three masses will be 0, 0, A0 and this. Now if you consider this 0, 0. So if we consider this as the origin, then its coordinate it will be 0, 0. This side has been considered as A, so this will be how much? A0. Y coordinate that remains same, and coordinate of this it will be again this and this. Equilateral triangle, so this will be 60 degrees, so it is A by 2. Again we can calculate this one because this length is A by 2, this angle is 60 degrees, so from that we can calculate this one. So using that you are getting this coordinate A by 2 root 3 by 2A, means it is 0, 0, this is A0, and this is A by 2 root 3 by 2A, this coordinate. Now once these coordinates are known, we can just calculate the center of mass. So here, if x bar y bar means this is the coordinate of the center of mass, because here it is in the two dimensional. Here you have this triangle. So we will have, if somewhere here is the center of mass, we will have the x coordinate of this as well as the y coordinate of this. So that's why we have taken this x bar as well as this y bar with the coordinate of the center of mass. Then x bar is m1 x1 plus m2 x2 plus m3 x3 upon sum of these masses. Similarly, we can calculate y bar. So x bar m1 x1, so m into 0, because here mass value is m, here it is m, here it is 2m. This was 0, 0, this is a0, and this is a by 2 root 3 by 2a. So we have to simplify this. So m into 0 plus m into how much? A plus 2m into a by 2. This is a. Divided by m plus 2m, so this gives you a by 2. And similarly, we can calculate the y coordinate. So if you calculate the y coordinate, so y coordinate of each mass is again m1 y1 plus m2 y2 plus m3 y3 upon m1 plus m2 plus m3. Y coordinate of the first mass, it is 0, second also 0, third it is root 3 by 2a. Substitute it and you are getting this. So this way we calculated x coordinate as well as the y coordinate. So from there we can locate it. So once we have, so y coordinate is at a distance of root 3 by 4a, and x coordinate we have calculated at a distance of a by 2. So here if you consider a by 2, somewhere here a by 2 and root 3 by 4a. So somewhere here we will have the location of the center of mass of this entire system carrying this mass m as well as 2m. I hope this is clear. So now we can consider the next question. So in this you can consider here a thin homogeneous lamina is in the form of a circular disc of radius r, of radius capital R. From it a circular hole is cut off exactly half the radius of the lamina and touching the lamina circumference, where is the center of mass. So we have this lamina and that is of radius r, that is a thin homogeneous lamina is in the form of a circular disc. So the nature of this, it is circular, radius is capital R. Now from this circular hole, from this a circular hole is cut off exactly half the radius of the lamina. So here it is just, it has been taken off and it touches the circumference. This side it is touching, one side it is touches the circumference. Radius of this, it is capital R, and radius of this is r by 2. That is given. Where is the center of mass of the remaining? Because it has been taken out, so obviously only this part is remaining. This part is remaining part, okay, except this. So we have to calculate the center of mass of the remaining. Now when we have to calculate the center of mass of the remaining, so we can use the concept of the negative mass here. We can consider that this is one object and there is another object placed over this. Mass of this object is suppose m1 and mass of this object is m2. Now if suppose this object is placed over this of mass m1, then how to calculate the center of mass? We could have simply done m1 x1 plus m2 x2 upon m1 plus m2 if it is along x-axis. If it is also along y-axis, then we will get m1 y1 plus m2 y2 upon m1 plus m2. But this mass is not part of this. This is a hole here. It has been taken out. So if addition of mass we are considering with the plus sign, then removal of the mass we will consider as a minus sign. That is the only thing. And that from there we get the concept of the negative mass, when this mass has been removed, not it has been added. So using this concept we will calculate the center of mass of this. So just you can see this. So here, suppose O is the center of mass, O dash is the center of mass of this object. Okay, now A is the common center of mass. So from here, m into 0, because m into 0, this entire mass, this circular disc, it is supposed to be concentrated at its center. So x coordinate of that, it is how much? 0. So m into 0 minus mass of this, it will be how much? M by 4, because radius of this is half of the radius of this. So this mass, it will be 1/4 of this. So it will be m by 4 into again how much? R2, yani x2. So x2, it will be equal to how much? This one. This is equal to how much? R by 2. So this is equal to R by 2, which is already given in the question. So this divided by m1 plus m2 in general, but here we have not added this mass, it has been removed, and because of that we will consider m1 minus m2, say m minus m by 4. So simplifying, you are getting this minus r by 6. This negative sign implies what? If we have taken this x as the distance from O, so it means the center mass of the remaining part, it lies in the left side of this point O, left side of the point O, at a distance of how much? R by 6. If it would have been plus, then it would have been in the right side of this point O. So that way we can calculate the center of mass. So where m is the mass of the whole circular disc, the negative sign implies it is on the left of this O. So here we have considered this as the reference point, and from this reference point the center of mass is at a distance of r by 6 in the left side of that O. So here what concept we have used? It is as usual m1 x1 plus m2 x2 upon m1 plus m2. The only thing is this mass is not part of this, it is not an added, it is not a combination of two masses. This part is the removal of this, and that's why instead of m1 plus m2 we have considered m1 minus m2. So we will continue this discussion in the next lecture. Thank you.